Hi guys, so welcome to this tutorial on making your own Christmas lights using your microcontroller, whichever one you have. Here I'm using a Teensy 3.5. Now, I understand on this model that I've got here, it shows that I'm using a Teensy 3.6, but the only reason why I'm using this one is because this was the only part that they had on this program that had the most similarities and enough pins to represent a Teensy 3.5, which is what I'm using physically. Let me just go through what I'm using. Well, what's going on here rather. So, in the top left corner of a Teensy, you have what is called the ground, and what I've done is I've connected ground to this vertical strip here closest to the blue lines. So everything along here highlighted in green is at ground. Now on the opposing side, we have VIN, the VIN pin, which is 3.7 volts to 5.5 volts. So the Teensy is transferring through this connection. It's transferring up to 5.5 volts all along this vertical strip here, closest to the red line. I have my 10 LEDs here, which are the LEDs that will form all the patterns. And I've got 5 different colors: green, yellow, blue, red, and white. And each of them is connected to ground. So even though this is this looks like the longest pin, the convention is the longest pin goes towards the voltage or goes towards the uh, the output pin or the pulse width modulated pin, and the shortest side goes towards ground. But here it looks as if the longest one is going towards ground. Don't worry about that. Just know that one side of the LED is grounded and the other side is connected to a resistor. Now each of these resistors are identical because apart from the wavelengths that the LEDs give out, the circuitry inside them is identical. So each LED is 220 ohms to regulate the power, otherwise the LEDs would blow. Now, because of the way we are modulating the blinking and also modulating how bright they blink, I've connected each of these to a pulse width modulated pin. That is, I can control the voltage to the pin before it gets to the LED, and that's what determines how dim or bright they are. Now, this part here, it doesn't, maybe it's so on a 3.6, but on a 3.5, this pin is pulse width modulated. So is this pin, so is this pin. All the pins that you see here, the 4 here and the 6 down here, they are all pulse width modulated pins. And I'll show you on the Teensy 3.5 schematic once we switch over. So these are all my LEDs connected to the controller. And just to reiterate, they only receive power if the controller deems it so. Okay, so you don't need to worry about connecting the LED directly to the voltage in. This is what we call parasitic voltage. This is always live. This is always live up to 5 volts. But if that was the case, if we plug these LEDs here, they would always be lit up. And we don't want that. We want them to only be lit up when whatever we put on the controller, that coding tells it so. That's why we've connected to these pins here. And these pins here will determine whether they get voltage and how much voltage they get in order to light up. In order to control the brightness, I have a tunable potentiometer here. Now, a potentiometer is basically a fancy variable resistor. As you can see, I've connected the 3rd pin to ground. I've connected the 1st pin to voltage in because it needs voltage. The middle pin is the analog input because this is an analog circuit component. So, and I've connected it to pin over here, which on my actual Teensy 3.5 schematic, it's not pulse width modulated, but then again, it doesn't need to be. It doesn't need to be pulse width modulated because I'm giving analog instructions into this pin. I don't need an output. So I don't need to modulate the signal that's going to the potentiometer because I'm twisting this and giving instructions to the microcontroller to do something. So that's fine. On the other side, we have a push button. Now the push button is connected to a 10k kilo ohm resistor, and it's also one of the other parallel pins is connected to voltage in, and the input. Now this is a digital input rather than an analog input. This is a digital input, and this is connected to a pin here. Now, on my actual thing, I think, well, you see it in the code. I've connected it to a specific pin. I think it's 38. Here it says 39, but we'll double check that. So the premise is I push this button and the patterns that these LEDs are flashing with change. And my full code has about 7 patterns to flash through. The one I'll show you basically has 1 in order to save time, but the proof of concept will be there nonetheless. Okay, so if you want to pause this video and just have a look at what's going on, that's cool. I encourage you to do so, but we'll switch over to the actual construction of the setup. So I've already connected all of the LEDs and the resistors and the jumper wires beforehand in order to save time. Now, just to show you what I mean about the pulse width modulated pins, you can see that on my schematic here, wherever you see PWM, that stands for pulse width modulated. That means at that pin I can control the exact amount of voltage that the pin receives, and therefore it enables me to control the brightness of each LED. My intention is to now connect a potentiometer onto this circuit and connect both the potentiometer and the push button to these pins down here, 39 and 38. And we'll do that now. So let's grab the push button first. If I can find the darn thing, there it is. And let's connect said push button right over here. So I've connected my push button as so. So now I need to give it power. Well, first of all, I need to regulate its power by putting a 10 kilo ohm resistor in series with it and then connecting it to ground. I need to give it power, and then I need to use a jumper wire and connect it to say pin 38 pin 39. We'll go with that. So let's connect this up. So I'm going to give it power. So I'm going to connect this pin like that, and I've connected it directly onto the voltage in strip where there's voltage coming from the Teensy. So this is at power. I now need to ground it, and I'm going to ground it with a resistor. So I'm going to connect this like so. So that push button is regulated and grounded in series with this 10 kilo ohm resistor. Now I'm going to use a jumper wire and connect this to pin 39. So I'm going to put my jumper wire so. And on the Teensy, pin 39 is down here. So that means I'm going to plug it right there. It looks a bit messy, but you know, hobbytronics and that. There we are. So that's our push button installed. Now let's install our potentiometer. So this is, I'm using a different kind of potentiometer because the other one was a bit flimsy. This one is very basic, but it's a lot more sturdier. The top pin The top pin is the analog input. The left pin here is going to be the one that I'm grounding with, and the right pin here is the one which I'm going to deliver power to. So I'm going to connect it as so. Just like that. Okay, just slot that in there. I'm going to use a black jumper wire to connect it to ground. Yes, it looks a bit messy, but what can you do? Then I'm going to use a red jumper wire and just feed it all the way to the voltage in strip here. Okay, and we have all our circuit components connected to ground and power. Now I need to use one more jumper wire in the middle pin to connect it to pin 38. So I'm going to do that as so. And pin 38 is below pin 39 down here. Okay. So that's how it should look at the end, or similar to that. Now the last thing I'm going to do before we get to the coding is connect it to my computer using my USB 2.0 cable. There. Hey guys, so in order to not take too much more time, I'm going to go through this code which I just prepared, but I will explain what I've done here. So at the beginning of every code, I write a brief description of what the code does. So I have this code programs an array of lights to blink in several patterns using the digital push button. It also programs an analog potentiometer to dim the lights manually. So as you all know, in this region here, I like to define what my pins will be and what certain values or outputs will be. So the first 5 things that I did was define my pins. I have my LEDs on pins 23, 22, and 21. As we saw from the Teensy schematic, all of these pins are pulse width modulated pins, which means I can control the voltage going to those pins, so I can dim them while they are blinking. The push button pin is on pin 39 and the potentiometer is on pin 38. So that's the analog input and that's the digital input. I've declared a delay time. So if you remember from the last video, delay is a function used to basically stop actions for a limited period of time. Nothing can happen again until that time has elapsed, and I'm declaring this as 50 seconds. So down below, as you can see here, down below, 50 milliseconds is the delay between when each light or several lights blink or turn on and off. I have P. Now P is a variable which stands for pattern number and its initial state is 0. This will raise and decrease as we push the button. But basically, when P equals 0, the lights on or off. When P equals 1, the lights will blink with a certain pattern. When P equals 2, the lights will blink with another pattern, 3, 4, so forth. In this particular example, I've only got 2 patterns. My full code, which I'll show again, has like 7 patterns. I have a button state, which is basically the state of the button. So it starts off, but when I push it, or when actually I switch on the microcontroller, it goes to high. So therefore, you know, it declares that it exists. But whenever I push the button, then the microcontroller registers that the push button is on. I have a pot pin value, a potentiometer value, which at the beginning is 0, but once I start twisting the potentiometer, it will have a value and the microcontroller will read it. Then this output value is based upon the potentiometer. Now, the mistake that I did in my last video was that I forgot to map the full range of the potentiometer to the microcontroller. The range of the potentiometer is about 1,000 values or something, whereas the microcontroller's range is about 255 values. So when I was trying to turn the potentiometer, and I was struggling because it was so sensitive, it was because it was very, very mismatched. Now, this output value is the result of a mapping between the potentiometer and the actual microcontroller, which I will talk about down here. In my void setup, I declare my pins as whether they are output or inputs. My 3 LEDs are outputs. They get instructions to just turn on or off. And my button pin, this is going to be a digital input, and my pot pin, my potentiometer, this is going to be an analog input. The void loop is the code which runs perpetually. So my button state is based upon the digital region from the button pin. So I press the pin, it gives a reading, it gives a digital region, and that will change the state from 0 to whatever. My pot pin, so as I twist my potentiometer, it's registered as an analog reading, and this will be stored as pot pin value, which initially it was 0, but once I start twisting the potentiometer, it becomes some certain value. I now take this value and I map it with my microcontroller using this map function here. And this allows me to scale the values of the potentiometer to the values that the microcontroller can read coherently. And I use this function called map. And the output is this output value. And this output value is what I will use to dim or brighten the lights. So I have an if statement which says that if the button state is high, that is, if I press the button, then I change this variable P. P is the pattern number. In the beginning it was 0. Whenever I push the button, I add 1 to this pattern, to this variable, with a delay of 50 milliseconds in between. So I push the button and P becomes 1. If P equals 1, do this pattern. Now you can see that this pattern just loops over and over again. The first LED turns on, then it switches off, and the second LED turns on, that switches off, and the third LED turns on, and it cycles back again with 50 milliseconds in between each particular section of the pattern. If I push this button again, I add another 1 to P, and P becomes 2. And when P equals 2, I've defined this pattern here. So all the lights gradually turn on until all of them are on, then they gradually turn off again until all of them are off, with 50 milliseconds in between them. And notice how I'm using output value, where output value is the result of whatever I've turned my potentiometer to. Now this, you can read this as, this is a certain voltage. If my potentiometer is quite high, then this output value will be quite low, and there will not be a lot of voltage on the LED, so it will be quite dim. If I twist the potentiometer another way, then this value will be higher, so I'm delivering more voltage to the LEDs. So basically, I'm modulating their signals so that they're on for longer and they appear brighter. And then if I press P for the third time, all the LEDs switch off. This is equivalent to you having a set of Christmas lights and you press the button, the setting enough times so that it turns off, and then P resets itself to 0 so that I can cycle through all the patterns once again. So I have my my circuit board connected. So let's first of all verify this code. And it should accept momentarily. Great. Let's upload it. Uploading takes a lot shorter than verifying. The verifying must be a very slow process because it's reading through every line and then, you know, just determining whether it's readable or not. Anyway, you heard that. So the code is uploaded onto the Teensy. So let's check it out. So I've just darkened the room so that you guys can see. So I press this button and the lights turn on. And just know that I can also dim the lights also by twisting the potentiometer. So if I twist it this way, the lights should start becoming dim. There we are, they start becoming dim. Let's brighten them again and switch to the next pattern by pressing the push button again. So that's the next pattern. Let me dim that also. There we are. Let's brighten that again. Push the button a third time and it should reset P to 0. There we are.